Welcome back to the Solutions Manual. In this video, we will solve the problem 2-32 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So to solve this problem, first of all, we have to resolve these forces into x and in the y components. So for F1 force, I have a vertical component and a horizontal component. Similarly, for F2 force, I have a horizontal component and the vertical component. Let's label them. So for F1 force, the vertical component is F1 cos 45 degrees and the horizontal component is F1 sin 45 degrees. Similarly, for F2 force, the vertical component is F2 sin 30 and the horizontal component is F2 cos 30. So far we have resolved our forces into their components. So now we have to find the resultant force. So for the x component of the resultant force, which is Frx, we have to sum the forces in the x direction. I am considering right hand side as positive. So we have F1 sin 45 degrees and F1 is 200 newtons. So 200 into sin 45. And we also have F2 cos 30, and since it's directed in the negative x-axis, so we would take it as negative. The value of F2 is 150, so it's 150 cos 30. So upon simplification, Frx comes out to be 11.52 newtons. Now we have to do the same for the Fry, the y component of the resultant force. I'm considering up direction as positive, and it is equals to the sum of the forces in the y direction. So we have F1 cos 45 degrees and F1 is 200. So 200 cos 45 degrees. And we also have F2 sin 30. So it's positive 150 sin 30. So upon simplification, Fry comes out to be 216.4 newtons. Now for the magnitude of the resultant force. We can use the Pythagoras theorem. So it is the square root of Frx square plus Fry square so we have a square root of 11.52 square plus 216.4 square. So upon simplification, the magnitude of the resultant force comes out to be 216.71 newtons. So this is our first answer. We also have to find the direction measured counterclockwise from the positive x-axis of the resultant force. So for the direction, If I draw the resultant force on the xy plane, then it would look something like this. This is the x-axis, this is the y-axis, this is the negative y-axis, and this is the negative x-axis. So we have frx, which is positive, so directed along the positive x-axis. And we also have fry, which is also positive. So using the head to tail rule of vector addition, this is the fry, and the resultant can be drawn from the tail of the first vector to the head of the last vector. Let me label them. So this right here is fr, this is fry, and this is frx. And since we have to find the direction measured counterclockwise from the positive x-axis, so we have to find this angle actually. So for theta, we can use the ratio of tan. So tan theta is equals to the magnitude of fry over the magnitude of frx. So tan theta is equals to 216.4 over 11.52. So if you take the tan inverse of this value, then theta comes out to be 86.95 degrees. So this is our second answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the resolution of the forces or in finding the direction of the resultant force, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.